Good morning, everyone. Today we will be talking about a presentation that I tried to wrap everything, summarizing the theories and the main design principles for designing space habitats or space stations. And that will include, of course, Earth analogs.
Sorry, Samit. Sorry to interrupt, but maybe we just give it 1 minute because I think also Glavki needs to start the streaming
Okay, sure.
on
No
YouTube.
worries.
Just a few seconds.
Yeah.
We'll
Sure.
give you so you don't miss any of
No, that's
the
okay.
top.
Just text me when you're ready. Okay.
Perfect. Well, I think we'll get a message from Glavki.
Okay.
Okay, perfect. So we're gonna get started. Thank you all for joining us today. This is our first session in the Jordan Space Research Initiative's Space Architecture series. We at JSRI are working on establishing an analog research facility in Jordan, bridging sustainable development with space exploration. And we are currently hosting a space architecture competition for people to get involved in the design process of this facility. And today I'm very happy to welcome Dr. Samit Sayary, who's going to give us a lecture on designing lunar habitats. So welcome everyone. If you have any questions throughout the presentation, please put them in the Q&A. Otherwise, we will also have 10-20 minutes at the end, so you can ask your questions to Dr. Samit. And with that, I'll hand it off to him.
Thank you, dear Saba, for the presentation and for the introduction. And thank you guys for coordination and organizing such an event. It's really my honor to be among you here today. My thanks also are extended to the MVA, Moon Village Association, for sponsoring and supporting us. So today's lecture, it will be a set of design principles and theories that I try to wrap up just to give the audience, our participants in the competition, the main guidelines. Yes, I do believe it is called designing lunar habitats, but I prefer really to point out that it is a design principle for all space habitats, especially planetary surfaces. And that also will include the Earth analogs. So without further ado, let's just start in the presentation. First of all, I would like to point out a very important note by Da Vinci and a quote by Da Vinci, where he indicated that develop your senses, especially learn how to see, realize that everything connects to everything. And this is the key that will be starting our presentation today. Everything is connected to everything. And this rule applies directly when we are talking about space. So we cannot really separate astrobiology from architecture in space or psychology or physiology. All sciences, and especially STEM sciences, are also connected to what we do. So why space architecture? Why are we even thinking in space colonization? The first thing, there are many scenarios. We have to really point out that there are utopian scenarios and there are dystopian scenarios. So let's start with the dystopian scenarios or the bad scenarios. First of all, when the scientists really shout out that it is very important and crucial for human race to spread into space to avoid the extinction level events or the extinction itself. You can call it extinction level events, annihilation events, mass destruction maybe. And maybe in the past there was a very known word that is known in the weapons of mass destruction. This word today started to diminish really and was replaced by what is called doomsday kind of weapons. So humanity is growing even in the militarization in a very scary scenarios. So just a couple of missiles maybe could end life in half of the earth. So first, Stephen Hawking famous quote when he started by, I don't think the human race will survive the next 1,000 years. And later on, before passing away, he just replaced the 1,000 years by a couple of 100 years. So it's just accelerating. We are accelerating into our inevitable destiny. Unless we spread into space, there are too many accidents that can befall life on a single planet. But I'm optimist. We will reach out to the stars. But as we are talking and discussing dystopian scenarios, we also have new opportunities, or the utopian scenarios. So one of the pioneers of this scenario is Elon Musk. Elon Musk has the aspiration to make humanity a multiplanetary species. And later on, also, we cannot forget money, space economy, the real engine and motor that is moving the development and the advancement in everything. And maybe I can refer to Jeff Bezos when he referred that he would like to achieve the Blue Origin to build the heavy lifting infrastructure that allows for the kind of dynamic entrepreneurial explosion of thousands of companies in space and like to keep Earth as a green planet for our habitation. And finally, the fun. We cannot live as human beings without fun. And when we talk about fun and space tourism, we can refer to Richard Branson, Virgin Galactic's leadership. He expected that millions of space tourists would want to fly in the next decade, but now, of course, the private sector is including the space tourism and including, of course, the space economy, and everything is, it's you can really just point out that one company will specialize it in space tourism. It's all growing everywhere. So, possible Earth analogs for a space application might include the Antarctic, or the airborne, or a desert space, or high altitude underground submarine settings, isolated ecological systems. And all of these 7 scenarios also applies when we talk about designing for extreme environments. So it is space architecture is a part of the bigger umbrella called designing for extreme environments. So what are the 10 hazards that we have to take into consideration and the challenges? I'd like really to replace the word hazards by challenges, because challenges implies that it is a problem or an issue that we can overcome. So the main 10 challenges, starting with the vacuum. You don't have oxygen, you don't have air pressure, you don't have anything to breathe. Number 2 is the cosmic radiation and the solar flares. And the cosmic radiation, we have 3 kinds of radiation: alpha, beta, and gamma rays. And the most dangerous, of course, is the gamma rays. And the solar flares, which is associated by the sun events. It's not a continuous flow of radiation, but it can fry any living organism that is not shielded by the radiation shields. Of course, the extreme temperatures, that's starting from minus maybe 130 up to 237 degrees. So, sorry, it's the other way around, from hundreds above Celsius and hundreds below Celsius. And the extreme swings for this temperature that might result in the material fatigue of our habitats. Of course, the space debris and the micrometeors, they are totally different entities. The space debris is a man-made kind of debris. The micrometeors is a natural debris, but they both are like continuous projectiles bombarding and shooting at the speed of very high speeds, which might damage any kind of structure. Either it is an orbital or on a planetary surface. We have 2 kinds of space architecture: the orbital space architecture and the planetary space architecture. In the orbit, we have the problem of the space debris and the micrometeoroids. But on a planetary surface like Moon or Mars, the micrometeoroids are the only hazard that we have. And of course, when we design a space analog, the space debris and the micrometeors might not occur. Many of these hazards might not occur due to our designing on Earth. But when we simulate the same living conditions, we have to take all of these parameters into our consideration. Also, when we design on a planetary surface, we have the harsh terrain of a planet on a planetary surface, which means that the landing will be difficult. So we have to choose a site for the ease of landing, and this is a very important parameter. Also, we have to take into our consideration the vast distances and the wide distances between planets, which is translated into the payload constraints. Any kind of heavy lifting vehicle, space shuttle, or rocket has a very limited volume and weight according to its payload dimensions. So the farther we go, that means that the less the payload that's allowed due to the more fuel that is needed to fuel and the engine of the rocket. Lack of resources, including water and building materials and everything. Of course, also this is another parameter. So, for example, on Moon, we prefer the North and the South Pole and the deep craters that is shielded from the sun rays. And scientists do believe that there's high reserves of water in there. So the lack of resources also is another challenge. Resources, either it is a natural resource or a man-made resource, like building materials. So we have also to replace the artificial building material with natural building material, or what is known as ISRU, in situ resource utilization. During building or on a site like Moon or Mars, any planetary surface, we have another very hazardous challenge, which is the regolith contamination, which might lead into serious damages in lungs and respiratory system. It might escalate to a carcinogenic cases. So it is very important, and of course, it causes abrasion of the engines and the motors because it is a very fine dust that enters from the slightest openings into the engines and into our respiratory system. Another problem or a challenge that might exert some damage to our cardiovascular system and our muscles and bone mass is the micro or low gravity, which means that we have to train at least for 2.5 hours per day just to overcome this problem. And last thing is the tight habitable spaces, which might cause many nervous breakdowns and many claustrophobic sufferings. And of course, smart design and wise design should be considered when we design for space. So this is a summary of most of the space challenges. And the most important challenge is the unknown. What is the unknown? We are still learning. We didn't develop advanced kind of habitats in space. The only kind of habitat that we have built and is rotating is the ISS, International Space Station. So we are learning, and we have learned during the last 20 years a lot of issues and a lot of science regarding the space and the space medicine and space shielding, but still we didn't really build on a planetary surface, which means that we will start learning by building. So regarding as many challenges as indicated today, but there's also the unknown kind of challenge that might occur and we didn't really take into our consideration. So this is the summary, just to point out the differences between the orbital architecture and the planetary surface architecture. So for the micro gravity, we have the micro to zero gravity on the orbital, of course, but on a planetary surface, it's also part of the problem. It's a partial problem. We have just low gravity. On Moon, it's 16.8 from the gravity of Earth, and Mars, it is 38% of the gravity of Earth. But into the orbit, of course, it is much more severe because almost we are in the free fall or in a zero gravity. The extreme temperatures and the temperature swings exist in both. Radiation exposure also exists in both. Micrometeors and or space debris impacts. In the orbital, we have both space debris and micrometeors, but on planetary surface, only the micrometeors impacts. The vacuum are in both, but maybe on Mars, it's the only we have like a toxic kind of atmosphere, but on Moon we don't have an atmosphere, and orbit also we don't have an atmosphere. The vast distances, higher cost than orbital, of course, when we are targeting a planet like Moon or Mars, which means further distance, so further fuel, so a much more limited payload, and that escalates the problem. The regulus dust is existing only on the planetary surface. Also, the harsh terrain, challenging terrain exists on planetary surfaces. The tight spaces are in both, but it might get a little bit better if we use the ISRU, which is the in situ resource utilization building with the local materials out there. Sorry. So that is the tight spaces and lack of resources. Closed loop recycling strategy is applied, and that means that we have to use a life supporting system. Also, a life supporting system will be used on a planetary surface. We can turn into a natural based life support system, which will be much more better on the planetary surface. Our physiological challenges will include the bone mass loss, muscle weakening, cardiovascular system weakening, vision blurring, deterioration, sensory, and motor function. And please always take into consideration that those are challenges. We can overcome challenges. We are very smart, and our history proved that we are very smart in solving challenges. The psychological challenges are a little bit more. It starts from the cognition and sensory defects, confusion, distraction, psychosomatic reactions, emotional liability, weak appetite, unfulfilled cravings, things that you miss on Earth, and homesickness, Earth nostalgia, claustrophobia, hostile behavior, which was proved during the behavior of the astronauts, depression and anxiety, and these are two different problems. Depression is not anxiety, by the way. These are two problems, and of course, sleeping disorders due to the jet lags and due to the absence of the circadian rhythm. But I always believe that smart design and good design could solve like 90% of those problems. And then comes the adaptation. When we adapt to the new environment and new environmental parameters, will reach the 100%. So after presenting the challenges, let's refer to the ideal human physical comfort zones. The gravity, we can live in a gravity from the 0G to the 1G, but we need to make more exercising and dedicate more time for our physical exercising just to overcome the muscle and bone mass decrease, and of course the cardiovascular system. The ideal temperature should be from 22 to 27, relative humidity from 40% to 60%. Of course, against the space debris and microbes, we need complete shielding. The pressure would be ideal from 10 to 15 Pascal PSI. Sound from 0 to 60 decibel. Diurnal cycle, which is also related to the circadian rhythm, we need 24 hours per day. 12 hours would be for awakening, maybe 12 hours for sleeping, and not sleeping to be precise, but the day and night cycle. The light from 0 up to 750 lux. More than that will be really affecting our vision system. And the radiation, the maximum allowed radiation is 50 radiation. And of course, the lunar and Martian regolith, the complete prevention will be the best for protecting human life. Let's now talk a little bit about the modules or the space module. The space module is an internally pressurized element intended for habitation. Most of space modules are built in rounded volumes, of course, to withstand the interior pressurized environment. Like the 7-Up or soda cans. Soda cans are designed in a cylindrical shape for the same reason, because the internal pressure are much more than the exterior pressure. The main problem with the designing space modules and space habitats, then the challenge that is exerted on the skin and the structure, that most of the pressure comes from the inside, not from the outside, like on Earth. Also, we are avoiding many of the sharp corners, which concentrates the stress and make container more fragile. And for that reason, spherical and cylindrical volumes, as I mentioned, are the ideal than cubical. We have 8 different modules. Most of the space modules, either it is a planetary surface or an orbital, is not really out of those 8 geometrical shapes. And modularity or modular design principle. The modular design principle is another very important for the expansion and growth of our space habitat or space station. So by designing modular design, that means that the entrances and the egress should be located, and the strategy of location of the entrances and egress should be studied to guarantee the expansion as pre-planned for the mission. For the classes of architecture, according to the classification of 1997 of NASA, we have 3 kinds of space class architecture: class 1, class 2, class 3. Class 1, where you build everything and test everything on Earth and ship it as it is into space orbit or into a new planetary surface. And it is referred to the hard shell module. Class 2 is a prefabricated space architecture. You fabricate most of the parts on Earth, but you deploy it and expand it and might really bury it under a lunar regolith or a Martian regolith to shield it from radiation and micrometeoroids. And the third one, of course, which is totally built in space, is the in situ resource utilization. And that is the most promising kind of architecture that we believe will have a high potential. It should be, of course, all of the 3 classes should be airtight, watertight construction, preserving all of the air inside it and the pressure resembling the Earth pressure also inside it. So that would be the 3 classes. Food production or plants in space. We have 4 categories that we should take into our consideration. The nutrition plants, of course, which are the vegetables and fruits. Medication plants, you can't really on a planetary surface get everything from Earth, so you have to be independent a little bit. So we have to plant medication plants. If we are using the second type of the life support system, which is a natural life support system or a nature-based solution, we need also oxygen bombs, and there's a high list of NASA plants that had indicated that it is so generous in generating oxygen and absorbing the CO2. And of course, the last kind of plants in the industry and the biofuel plants like cotton for bamboo for gadgets or biofuel for some kind of fuel. So these are the most important. The most important is number one, the nutrition, then followed by the medication, followed by the oxygen bombs, and last thing, of course, is the industrial and biofuel to sustain and maintain a kind of life on a planetary surface. The way of cultivation, we have four different techniques: the hydroponics, the aquaponics, the aeroponics, and last one is the fogponics. The most known kind and approved is the hydroponics, but the four principles, which is representing, by the way, what is known as the horticulture. And our audience, if you'd like to further read more about these concepts, you just have to type on even Google or Wikipedia or Britannica, and you can find excessive information regarding all the four techniques. My apologies that I don't have really much time. It needs maybe weeks and months to teach everything about space architecture. So this is a very brief 1 hour today presentation that I tried to gather all of the key information that is essential and necessary for any designer or architect to design for space. So if we designed a space habitat, we have to secure the four things that are indicated here: the oxygen, water, and dried food, and water for food and for drinking. You need water for sanitization and water for drinking. So this is just a very quick schedule by NASA of our human needs. And please take into consideration that the one on the left is the one on Earth, which means a normal kind of lifestyle. But when we design for space, the numbers are much more less than on Earth, because water, for example, is the most precious commodity in space, even more than gold and platinum. So we have to be wise in using them and do not act on depletion of our resources. We have discussed maybe the life support system, but I would like to point out that we have two kinds of life support system: the environmental control and life support system, which is the engineered kind of life support system, ECLSS, and the controlled ecological life support system, CLSS. Most of the NASA engineers that I have met prefer the first one because it is predictable. The quantities and the ranges of oxygen and consumption of the oxygen CO2 are calculated precisely, and everything is calculated and predicted and anticipated. On the other hand, the life support system, as it might on the long run be much more better for our existence, like the biophilic principles, which is supporting our psychological part, but nature is unpredictable. Trees, for example, have psychologists like human beings. They can suffer depression. They can have high morals. So also the rate of oxygen, for example, for trees also varies. It is not standard. But if we monitor that using an AI system, artificial intelligence system, computerized system, we can also reach the best levels of it. Talking about entrances or egresses, we have basically four different types. Starting the planetary airlock system, it might be equipped with an air showering system just to clear the contamination of the regolith. And later on, it was replaced by the suit port, where you can leave your suit outside and just through the hatch on the back of the suit, you can enter to the habitat and get outside it. Of course, there's also the suit lock, which is a hybrid system between the planetary airlock and the suit port. And the last one is just a docking hatch, and that one is appropriate when you just hatch two modules, or you connect and attach two modules. So you just need a docking hatch and to open the two docking hatches together and connect them, so you can extend your habitat. After the basic theory, let's now switch to some of the projects, some of the experiments. And the projects, all of the presented projects, are based on other existing technologies and or near future technologies that might inspire our audience to generate solutions for their competitions. Of course, all of the presented projects are also internationally awarded and reviewed by space experts and or astronauts that have been trained for years to be astronauts. The main basic design, fundamentally, the community-centered design, that is the school of thought that I am following and I'm developing through years when I'm working in space. It's a 3 steps manifesto. The first one is digging deep in the old knowledge and science accumulated through thousands of years to capture the hidden values, intangible strength of our human legacy. And just to clarify out this point, let's just refer to the ISRU. I have indicated in the class 3 architecture of space architecture, there's something called the ISRU, or the in situ resource utilization. In summary, it is using the local resources to build. So if you are using the ISRU method to build on Moon or Mars, you have to ship out the robotic arm that will be 3D printing the new habitat. So this is the top-notch technology. This is the cutting-edge technology that we have reached and been required by NASA. First time I read a NASA brief in a competition was in 2015. They asked us, and before that, the ESA in the Moon Village project. But let's do not just forget that this is a typical human behavior and attitude thousands of years ago we used here on Earth. And by proof, if you visited the desert communities in Tunisia, in North Africa, in the vast Sahara Desert, you will find a lot of sand kind of houses. If you just walked a little bit to the north and reach the North Pole, you will find the most appropriate way is the igloo, which is built by the ice. In North Canada, North America, and Russia, and many of the Scandinavian countries, you will find the timber kind of construction, which is prevailing due to the abundance of timber construction. So that means that we are following the ISRU thousands of years ago, and we have developed a traditional knowledge system. And thank you, Ms. Sahba. Also in Petra, it's the same applies, using the rocks and digging in the mountains. So this is a typical human behavior. So we cannot ignore the experience accumulated through thousands of years ago. Our ancestors are mastering this kind thousands of years ago, and we just turned them down and started to embrace skyscrapers, concrete and glass. But when we face harsh environments, as our ancestors did thousands of years ago, we will follow the same principles just like our ancestors. On Moon, we are just like thousands of years ago, just like our ancestors. But today, we also cannot ignore that we have a lot of computer technology. We have AI systems, we have parametric design, we have simulations, all kind of simulation, we have satellites. So by rethinking and re-experimenting our ancestors' experiments using the cutting edge technology, we can reach really and literally beyond the stars. And the last one is the responsibility, the social sustainability, our responsibility for our future generations. Even in our lifetime, if we didn't experience living on Moon or on Mars, but we have to deliver them our knowledge system and to allow them to continue what we have started. Science had been developed through thousands and hundreds of years ago by passing the science from a generation to the other. So a lecture like we are conducting today, or experiments like competitions, exhibitions, publications of the scientific conferences and journals, all of those are ways of transferring this knowledge. Everything today is recorded and uploaded into the cloud or a YouTube service or whatever. So we have to deliver them what we have reached, so they and inspire them so they can continue what we have started. We are on the verge on starting a totally new civilization. We are the pioneers, the first generation who is designing to trespass the boundaries of Earth. And our experiments, the initiative experiments, that is crucial for the future generation, so they can develop and learn from our mistakes. And we will make mistakes, but humans are always smart because they learn from their mistakes. Sorry. So the first project that I'll be presenting today is called the Lunar Oasis. And by the way, there's another version called the Martian Oasis that I'll also be presenting today. And it is a third class kind of architecture using the local materials in building. And let me just real quickly, tell you about the phases of colonization according to anthropologists and anthropology. We have three different phases of colonization. The first phase, when you just discover a new land, you stick the flag of your nation and then bounce back to your original home country, like Columbus did in America, like 400 years ago. And we have already passed this phase during the Apollo Mission 11, when Neil Armstrong and Buzz Aldrin had just landed on Moon and announced that they have put their feet, and one small step on Moon is a very huge leap for humanity. And the second phase, when immigrants, temporary immigrants, start to flow and flood to the new discovered land and start building temporary kind of outposts. And I think this will be the start of Artemis program. The Artemis program announced by NASA in the few coming years, it will be the second phase. The third phase, the new settlers or the immigrants will consider the new land as their home. So they will go to the new land with the intention to stay and not to return back or bounce back to their countries. And by the way, there is a fourth kind of colonization, which is the new generation that is born on the new land. And actually they declare independence and they declare separation from all ties. And really the fourth kind is always associated with military conflicts. But my settlements is a third kind of settlement with a permanent base on moon or a permanent space station on moon with the intention for people to stay. So it's a sustainable and to maintain and sustain human life for very long time periods. Why the oasis? Historically, the oasis was always associated by the source of water that people gather around and the flora and fauna start to flourish around. And this is the start of a settlement, which might grow into a city, and the city might grow and connect with another city and city to form a nation and a civilization. And that what we have learned from history. So when we return to the beginnings, it is always important to search for a source of water, and the source of water is available on moon, which is known as the frozen water under beneath the lunar regolith and in the deep craters that is shielded from the sun rays. So we have the source of water, so we can start a new kind of life there. But also we have to learn a lot, not only from our ancestors and their experience, but also to emulate nature. Nature, in a science known as the biomimicry, we learn nature is the model, nature is the mentor, nature is the offering the engineering solutions to most of our complicated and complex challenges. Like the tree, for example, I'll be talking about the project called the Tree of Life and how I mimicked the trees and their connection and their sharing of resources. The father of modern architecture has a very nice quote. He told us that, it is always life that is right and the architect who is wrong. So we have to respect nature. We have to learn from nature. We have to act as nature, and our buildings should be acting as nature. And this kind of science is called the regenerative and the bioregenerative kind of architecture. So why the circle? The circle is historically hardwired in our brains that it reflects the community, the continuity, the strength. Most of the folkloric dances are done in a circular formation. When we gather around a fire in the tribes, the primitive tribes, when they gather around the fire, they are in a circular formation. So even in our logos, when we refer to the community, we refer it as a circle. So from these influences and inspirations, the project Lunar Oasis was born. Also, we have learned from our ancestors a behavior called the anthropization, which is changing and taming nature. So our ancestors used the anthropization, for example, to start using mountains as a farmland due to the inclination, the hard inclination and topography of the surface. They just stepped surfaces and made flower boxes out of it, or in farming terraces. So anthropization is also another thing that we have learned from our ancestors, and using the parametric design with the new word using the parametric design is called the contouring algorithm. So the anthropization, the one that we are seeing or viewing in this slide, will be applied, but using an algorithm called the contouring or the contour crafting. Yes, we can. I think the session is recorded. Thank you, Mr. Safwan, for sending me. You can later on refer to the recording, I think, with a coordination with the organizers. So one of the main lessons that were applied and used also in the design of the Lunar Oasis is the ant colonies. And the ant colonies is one of the most complicated and one of the most sophisticated kind of engineering piece. Ant colonies is housing thousands of ants, and it is resisting all kind of existential risks, including floods and storms and maybe all kind of hazards that you can imagine, predators, and it is perfectly working using a very primitive life form. For us, we consider ants a very primitive life form, but it is a very complicated and a very sophisticated, and it is proof that their work is a model and a mentor that we have to learn from. So the undulation of the circles and the concentric circles with the main core in the beginning as acting as the main vent or ventilation system is also applied in the new colony. I also referred to the work of Mr. Marco Cohen. Mr. Marco Cohen is a very known figure in the industry. He was the NASA chief architect for a very long time, and he had a lot of patents and a lot of research. So designing after the much of the readings of the papers and patents of Mr. Marco Cohen, I tried to understand how lunar habitat is designed. Where the location? Now, if we are talking about the location, historically, the man or mankind used caves as the natural shield against radiation, predators, and every kind of hazard. And it is something that we have learned also from our ancestors. The cave actually is the first form of shelter that protected human being from all extreme harsh environments. And the same applies for moon. This is another research conducted by Purdue University and a 3D model of the lunar lava caves, and it is believed that the lunar lava caves has most of the ideal conditions that might start a civilization. We have high reserves of water because it is shielded from the sun rays, so there's no evaporation of the reserved water. The temperature swings are minimum in this case. It is naturally shielded from radiation. It is naturally shielded from micrometeoroids, so everything is perfect. The only problem that it is not exposed to sunlight, but we can really replace that by artificial kind of LED system, LED systems, or even by fibers, optical fibers. We have invented several solutions to overcome the 10% or the maybe 15% that is needed to sustain life. And from here, I started taking the Phyllis crater, which is near to one of the poles where you can find abundance of water. And this is a 3D model that is built just to imagine the scale of the lunar lava cave, and several colonies are just arranged on a linear arrangement with one main spine connecting all of those colonies together. We have learned also from our ancestors that it is very important and crucial to document our history. So starting for the first phase of colonization in 1969 and ending with the fourth kind of civilization, the first born child on moon, and this wall mural will be 3D printed with the new colony and the inner walls of the Lunar Oasis. The Lunar Oasis is gathered around a frozen source of water with a reactor, main source of power, dug below and far away from the habitation system, and having a park so people can really go and stretch their legs and to eliminate the claustrophobic effect. You can find another lesson learned from the ant colonies, that there are separate independent compartments and several independent compartments. So if any failure or wall fatigue or wall collapse or any kind of damage on the outer skin might occur in one of the modules, the rest of the modules are separated and independent. So the failure or the contamination even, or any kind of existential event that might occur on the new colony might not crawl to the other compartments. So everyone is protected with a safe house and an airlock surface access unit, and food production plants just beneath the trees to cultivate the trees and use it for the food production of the colony. Powering solution are three main powering solution, and I do believe that the diversity of the powering solution is crucial also, just in case of the failure of one of the powering solutions, so the other solutions might act. The first one will be the solar satellites, which will be deployed in the lunar orbits, just to start beaming and start gathering all the solar power and beaming it in a low microwave waves to the ground antennas that will be collecting all of those power and start powering the colony. And it is important for the lunar surface because the lunar surface has 14 days of continuous solar exposure and 14 days for total darkness under night. Yes, the south and the north pole are a little bit better because sun is just rotating and around the solar pole, so you can have a continuous flow of solar panel. But if with a solar satellite, you have the freedom to build anywhere on moon. And during the construction phase, it will be important for the solar satellites until we just deploy our first small nuclear reactor, or maybe fusion reactor if we possess the technology in the near future. So that will guarantee and sustain and maintain the human life for a long period, and it will be the main source of power. And last thing is the piezoelectric flooring, which is encouraging the astronauts, encouraging the crew members to exert some physical effort, maybe physical exercise, maybe even dancing and having fun. And with each movement on the floor, it will also generate energy. Energy is important for the life support system. Energy is important for melting the frozen water. Energy is important to maintain the temperature and the oxygen flow and everything. So you are running and having fun just to ensure that there is much more energy. So it's like a closed loop system. Everything is connected to everything, as Leonardo da Vinci quoted at the first slide of this presentation. The form reasoning and the form generation, as I have indicated before, it is inspired from the ant colonies, dividing the compartments into major compartments and then secondary compartments until every compartment and built in the contour crafting or the contouring method from the anthropization. So here there is a blend of our human culture and nature all weaved together. Also, another lesson that is learned from our ancestors is following the sacred geometry. The sacred geometry, it is the geometry of the universe that you can find. It's not, of course, a coincidence that you find that all of the ancient temples in ancient civilization across China, ancient Egypt, Greek, and going to the Mayan in South America are following the same geometrical rules. So it is not a coincidence, and they have reached the conclusion that this is the most important and crucial kind of geometry that they have to follow, and we have also to follow the same rules to be in alignment with the cosmos and universe. The lunar food production, this is the plant, and the powering system will be providing a continuous flow of melted and clean water to the plants that will continue their purification and provide clean water for drinking and for the human activities and also for the trees. ISRU, or the in situ resource utilization, it is in summary using the local materials, but in the 3D printing method, we cannot use the same 3D printing methods applied on Earth. Most of the 3D printing methods applied on Earth is using the water as the main base for the concrete on Moon or on Mars or on any kind of a new habitat. Water is a very precious commodity that we cannot waste on construction. So we have to use totally different techniques. One of the techniques is called the laser sintering. And we have also the laser melting, which is much more better than the laser sintering. And we have recently the solar sintering, which is a more sustainable and less in consuming our power energy in building process. The solar or the laser sintering or even the laser melting are all following the same principle of exerting a very high laser beam energy to fuse the grains of the regolith together. On Earth, what really the bonding material could be the melted silica in the sand. On Moon and the lunar regolith, we have obsidian. Obsidian is a kind of glass that also can be fused using the high energy and can form at the end an airtight kind of construction and a very solid, shielded also against all kind of hazards. Sorry. The geometry. With another research from the Massachusetts Institute of Technology, or the MIT, they have conducted a research about what is known as the Gyroid Cube, or the minimal surfaces Gyroid Cube. And they have proved that it has a strength 6 more times than a regular cube, concrete cube, and they contain also some vacuum pockets, and the vacuum pockets could be used as an insulation for the thermal insulation to maintain the thermal comfort inside the habitat and shielding it from the temperature swings outside the habitat. And by applying the same principle, I started building the first prototype of wall using a modular cube of the gyroid unit, which is another experiments that were conducted to form a circular formation using 2 kind of prototypes. The first prototype using the ABB robotic arm, the excavator, which will be digging and storing the regoliths and filtering them, and then prototype B, which will be equipped with a 3D extruder and a high energy source to fuse layers of building. And after a study of the contour lines, I think it will be in the other slide, there is another study of the contour lines and the lengths of the contour lines, just to understand the quantity of the power needed to be consumed in building the habitat, to have predicted figures and numbers. We have discussed the colony powering. Last thing, having a clean courtyard. On Moon, there is a challenge that it is considered to be a challenge, but we can use it for our favor, which is the lack of atmosphere. The lack of atmosphere on the lunar surface means that there is no oxygen, no air, no wind, and on the other hand, there is no wind dynamics. On Earth, what really moves the dust into our homes is the air and the movement of the air and wind. But according to the Moon and the planet, the environmental parameters of Moon, no air means no wind. That means if we have cleaned the inner courtyard, we have no chance that any kind of regolith could move inside it. And this is a very important courtyard for people to stretch our legs to using their EVA suits, and they can enter into the habitable zone using their EVA suits, which will be not contaminated according to the vacuum cleaning of the inner courtyard, and at the same time it will eliminate most of the 10 psychological parameters that we have discussed earlier in this presentation today. The first award of this project was in Jacques Rogerier Foundation in 1918, and then later on, the same project was published as a scientific poster in the United Nations Office for Outer Space Affairs in 2021, and then it was turned into VArt Ukraine, into a virtual reality experience by VArt Ukraine, and it had also won another international award to be turned into this VR solution. And last thing was just a couple of months ago, when in the promo Moon Initiative, it has also reached its finalists in the competition held by them. After finishing the Lunar Oasis, the research line didn't stop, and I had a proposal from of the Gulf country government to study the possibility of building a prototype or an Earth analog that might be suiting Dubai's desert, and I have signed the agreement or the MOU for building and start developing another and called it the twin colony. So this will not only be serving as a Earth analog, it will be the first copy that will be built on Earth, which will precede another identical copy on Moon, and both of the two colonies will be connected via set of satellites. So it is in real time. If you'd like to control anything on Moon, you can just start by controlling. So each door and each button here on the Earth colony that will be shut down, on or off, it will be also shut on or off on the lunar surface. So both of the colonies will be just connected, and anyone who will be entering this Earth analog, it will be as if he is entering the lunar surface. We may be also learning from the Japanese program, which is called Avatar X. Avatar X, in summary, is just replacing human existence on the planetary surface by the robotic proxies that will be operated by the same astronaut, but on Earth. So by having our astronauts on a safe environment in an Earth analog on Earth, but controlling the same colony and collecting resources and conducting experiments on the lunar surface by the same copy of this colony. These are just slides of the Earth analog that is designed exactly like the lunar one, and it will be also a hybrid virtual space where you can meet your parents, you can meet your friends, anyone that cannot afford to go to Moon, but their people can really meet on the Earth analog, just in case that there is a crew member on the lunar colony. In 2019, I started developing another copy, which is suited much more to the Martian environmental parameters. Mars now is much more gravity. It has wind, so we can use its long fins in generating energy using the piezoelectric effect. The main cardinal direction of the Martian north, south, east, and west are also constructed as clues for any crew member and crew missions to guide them through the landing process. Where, as you see, this colony is built on the Martian surface, not in a Martian lava cave as on Moon, and that means that you can deploy most of the solar panels on the surface, and there is no need to use the solar satellites. The Martian surface also has very hard kind of wind, dust winds, which might block the vision and might block most of the connections between any kind of satellite and the Martian base. So according to the different parameters, also that resulted in a different kind of design. This is just a comparison between the Lunar Oasis on the left and the Martian Oasis on the right. Now you can find that there are three different categories of habitable zones. A very long airlock with a very high pressure air shower to decontaminate any astronaut or EVA suit even from the Martian regolith. We have, this is on the surface. It is built and constructed just on the surface. We have something below the surface, which is the farms and the food production units, and most of the experiments that will be conducted on trees. You can access and cultivate all of the trees just from below the unit. And the last one is the offices and the habitable living area, which is shielded, like 50% of them underground, and just 50% is constructed with the Martian glass that will enable the sunlight to enter to the habitable zone just to maintain the circadian cycle. So people now will be having 12 hours of sun light and 12 hours of darkness just to maintain our healthy kind of life. The construction phases are 4 phases: locating the ideal place using scanning satellites in the orbit, and then setting down the main cardinal directions and deploying all of the powering system at the beginning, and then followed by the boring and the digging process, automated of course by robotics, and last one by deploying the farm inflatable units, and it will be ready in the phase 4 for humans to start operating the new colony. Just a night shot for what is expected to be the lightscape study, just to have a lovely place and of course to support the psychological part of our human being. The inflatable part is just another developed competition entry that has won in 2017 the first award in Mars City Design in Los Angeles. So yeah, as you can see, it is a line of research that is started maybe from 2016 and is developed 3 years, and still it's a work in progress, and I'm still developing it, and I'll keep developing that just to ensure that this will be my legacy that I'll be delivering to the future generations, so the future generation can use what I have done and published to complete what I have started, and maybe that might offer a solution for humanity someday. Just to provide the reason for building the Tree of Life, this is 2 images of the same planet, which is Mars. The one on the left was in June 10, and the one on the right in July 31. You can see on the left that the most of the topography and the geography of Mars is just clear and obvious, but after the sandstorm and the dust storms, all of the features of the Martian planet is just covered and blurred due to the high sand and dust storms that really affects our solar panels, that affects our it blocks the sunlight and the sun rays. So, but on the other hand, the dynamics of the wind could be utilized and used with a piezoelectric effect, which is much more better than the wind turbines due to the low pressure of the Martian surface. The pressure on the Martian surface is just below 1%, maybe like from 0.6% to 1% of the air pressure. So that means that even the strongest winds on Mars will be very, very slight, will exert a very, very slight movement on blades. So those wind turbines that we have designed and developed on Earth will not be functioning appropriately on the Martian surface. And for that reason, I thought about using the piezoelectric effect, which is much more efficient. These are just renderings to understand how would it look like on a dusty day. And I started developing much of the prototypes. That was in 2017, until I've reached the first prototype. The first prototype, the oscillations that will be exerted during the Martian wind will provide this tree with all of the energy needed for the photosynthesis process. And it's a complete solution, expandable solution with a surface habitat just below the surface. It will be deployed using the heavy Falcon payload dimensions. So phase one is just inside the payload, and after the deployment on the planetary surface or the Martian surface, it start expanding using the memory-shaped alloys just to reach its final shape. And by exerting any pressure of the wind or even the dust, the slightest weight of regolith and dust will be oscillating this part, the extension, which will generate much of the energy for the tree inside it. A very nice book that really inspired most of my designs is called The Hidden Life of Trees. We have learned from The Hidden Life of Trees that trees are just total living organisms. Just like human beings, they have physiology, they have psychology, they have everything that they are talking to each other. They are connecting to each other, and they share resources. They share resources to their family first and their neighbors, and they send messages of any kind of possible hazards and coordinate together. So the tree that we are experiencing as just a solid state, it is a very livable, very living organism, just like humans. And that means that no tree could be designed as a separated or independent solution. So trees should be continuous connected to share resources, to send messages, and to allow even the crew member to move from one unit module to the other module. And after the first prototype, and during a workshop in the Los Angeles, supervised by one of the ex-NASA chief engineers, I started developing the second prototype, which will be much more lighter, and all of those fins will be just pressed into this capsule, and all of them are built using the Netanol. Netanol is a memory-shaped alloys that takes its final shape, and it resists any kind of damage, even if if a fierce kind of force will be damaging or bending or affecting its surface. It will just bound back to its original shape, and it will be moving freely. Each tree will be locating its ideal place using a very sophisticated kind of algorithms regarding the sun and the wind and the temperature, which will be appropriate for this tree. By the way, the inflatable membrane is a double membrane with an aerogel in between, just to shield the tree from radiation and from the swings of the extreme temperatures on the Martian surface. This is the first prototype, and the geometry that was developed for the inflatable just to dust off or brush off the Martian regolith, which might block the surface. And it is very important on a sunny day that the tree might experience the sun rays to conduct a natural photosynthesis process. But on a windy day or sun rays, when they will be blocked, it can just generate energy using the wires that you can find contoured on the surface of the tree. That was during 2017, Mojave Desert. That is the virtual experience of most of those projects in a UK-based exhibitions, virtual exhibition. And in 2021, in alignment with the United Arab Emirates plans to start their own Mars settlement in 2021-17, after just almost 100 years from now. So this is another developed prototype that was awarded also in 2021. And this is a natural life support system, nature-based solution, creating a micro ecosystem, just importing part of Earth on the lunar surface. With a micro ecosystem, also, you can gain circadian rhythm, you can gain biophilic design. Of course, you have an internal pressurized biodome, and you can capture all of the views which will support our psychology. So there is a visual connection with the environment. And last thing, there is a radiation shield. So creating the first healthy environment for nature, and the habitable zone is built using also the ISRU solution on the inside. The way of construction will be a little bit different. It will not be a 3D printing kind. It will be crystal pouring, which is another technique to solidify Martian regolith. So we can create natural shields from the inside, and all of this will be housed inside the biodome. And also to generate a smarter design. it is very important to follow the funicular formation, which is the formation of the natural land and dust by the gravity, and then contoured also using regulated 3D printing process. And last thing, the shields of the biodome that will be housing the whole complete geometry inside it. This is the main layout. This is just to imagine the scale of the colony with the heavy Falcon rockets. These were just the research offline followed to build a space habitat. Now, switching to Noah's Ark. Noah's Ark is a heavy lifting passive solution that will be orbiting Earth just to preserve our embryos, our seed banks, and everything to sustain life just in a case of an existential risk that might occur on Earth. So that will be our backyard. It will be carrying also crew members from 160 to 200 individual. And this sample group is known as the minimum viable population. These are the set of individuals that can reverse any existential risk and start a new civilization. So according to science, you need this number, and it will be designed to house this number. This is just a quick section indicating the fridges and the embryo fridges and the human sleeping pods and the biopods, and everything will be at the upper part, shielded, of course, from all kind of space debris and radiation. And there's another layer of shields, which will be also acting as a docking covered board for the landing of any space shuttle that will be shielded against space debris and also radiation. And there is the nuclear reactor, which is located remotely, just in case that something bad happens. It is also known in the space architecture that most of the nuclear reactors should be located in a remote location away from the habitable zone. And these are the solar sails, which is a passive solution, and using the solar rays to exert pressure. So the heavy lifter will be moving also using the solar sails, which will be deployed to gain also some energy. The diversity of powering solution is one of the key important elements that should be taken into consideration. After we have discussed most of our colonization, we just can't forget the space economy. So we have discussed solutions for the extinction level event, solutions for tourism, maybe for most of the dystopian scenarios. But now switching to the utopian scenarios about the space economy, we have learned from Earth that the industrial revolution had thrived after the invention of the railroad system, which was crucial and important to transport the goods from across great distances. And the new kind of railroad will be the orbital space elevators. The orbital space elevators is studied, and it's an old concept from the maybe 19th century. And now we do have all the technology, and it is very feasible according to our technology and financial feasibility to build a lunar space elevator, also according to most of the papers that I have been using in developing the concept. By the way, I do define myself as a science architect. So I'm a scientist architect. I use science to generate architecture and then test this architecture and participate with this architecture in international competition that is judged by space experts and astronauts, and then turn those projects again into scientific paper to close the cycle. So after my readings and the conclusion that I've reached, that we can build lunar space elevator using most of the material. Of course, the ideal will be the carbon nanotubes for the tether, but we can use Kevlar instead. And in conclusion, it will be acting as two kind of transportation system: an external transportation system to link the Earth with Mars and maybe beyond, and also an internal kind of transportation system to connect remote places, locations on Moon together. This is an exploded isometric with much of the studied material that will be used, and the number of shields that will be used. And all of this part, by the way, is housed also inside a lunar lava cave, and that is the reason for the linearity or the linear formation of the habitat. And then there is the superstructure, or the part that will be above Earth, above the ground of Moon, until it reaches the orbital station. This is the orbital station that also will be shielded from radiation and space debris, and it will be containing all of the shipyards. There's also, by the way, something called the orbital shipyard. It is a kind of space stations that is used for repair and for hosting and for receiving all kind of space shuttles. Of course, this is the retired Saturn V that will be replaced with a newer version of the space satellites. And this is the ground station, or the Terran, the lunar Terran station, that will be connecting the orbital with the underground. And the underground is designed with a biophilic design. It is like importing part of Earth, which is with its contours representing or reflecting the natural topography of Earth, containing now water and different and various forms of flora and fauna to support our life. It is a place designed for people, not just to count seconds or moments or minutes to leave to Mother Earth, but to appreciate every moment of their presence in the new habitat. It is a controlled ecological life support system, so the trees will be generating its oxygen, it will be absorbing its CO2. It's a very healthy place to live and to enjoy for entertainment and to exercise as well, as if you are exercising in nature. We're using an artificial sources of light that will be regulated as the circadian rhythm, so it will be offering 12 hours of sunlight and 12 hours of darkness, just to mimic the same conditions on Earth. This is the selected site. You can find in monitoring latest crater and the biomimicry of the human eyes. It's called, by the way, Project Iris, and Project Iris has two definitions. The iris is the piece of eye that is contracting and opening. So it is also a place, it's acting as a huge space telescope. It might be also constructed on the dark side of the moon, just to help us learn and know more about nature. So the main slogan even of the project, we will put an eye on the sky. But also in our human history, Iris was a Greek god that is defined as the messenger between the different gods. So Project Iris will be the connecting body of architecture that will be connecting Earth to Mars. It will be functioning with the same mythologies. So it is reflecting our human legacy, and it is also reflecting nature, and it is a part that reflects our humanity and our Earth. Powering solution, as in past, will be diversified into three different solutions. The first one is the solar satellites, and then there is the ground solar panels, and last thing is the nuclear batteries, 9 different nuclear batteries that will be powering the climber or the vehicle that will be connecting the orbital space station 96,000 kilometers from the lunar surface. Key of Life, which is also another project representing the gas stations that could be fueling and providing energy between planets. It will be the new Silk Road. It will be called the Space Silk Road. So there are 1, 2, 3, 4, 5 different stations along the orbit from Earth to Mars. So now we can have less fuel, which means more payload in our launching vehicles. And by passing by the space gas stations, it will be beaming to us many of the electrical energy and power that is needed to power our space shuttles reaching to Mars. It is also inspired from different variations of civilization, which all share the same concept, the source of power with the wings. It might be the sun, it might be the soul, it might be the source of life. So it is the same. It is something also inspired from our ancestors and from our culture and civilization. And it is also an expandable, using the principles of the origami art, just and to be transported in a payload of the Falcon 9 and then expanded into its orbit. So this is the mechanism of expansion and compression, just by deploying all of these capsules into orbit, and then it start functioning. This will be the antenna, this will be the solar panels, and the main storing energy unit will be here, that will be also beaming all of the microwaves using the antenna to all passing by space vehicles, with all of the elements, of course, that you can return to the recording and read in detail. It might function also as the main principal basic infrastructure even on Earth, on Mars. So it will be also connecting and covering much area, but it will be functioning in a reverse action. So gaining energy and beaming those energy to, to the Martian habitats. So this is another also version of the key of life. And it is called, of course, key of life because it will provide life to new habitats. Either it is an orbital habitat or a space Martian habitat. Last thing, Mars cycle, which is a self-balancing um, uh, kind of cycle that is above Martian regolith, and it is a technology, by the way, that BMW, I think, the one who developed the self-balancing, and maybe Honda as well. So it is an existing technology. So this will be a balanced kind of space vehicle with a very long antenna for communication and for powering solution. And also it is an origami-inspired kind of engineering. Space projects are not intended only for space. So my main slogan is we have to develop and learn space technology because we will need it someday on Earth. By the way, scientists consider that Mars is the future of Earth. Mars is a deserted place. So if we are still growing with the destroying behavior of Earth, we will someday reach the same result as Mars. So we have to develop the science. I do have a quote that I keep saying to my students. If we have the science and technology to terraform Mars, that will be the same environmental science that will be used to fight climate change on Earth. And following that principle, those are just samples of projects or house habitats that is designed for Earth, but using and following the same space design principles. Each project of those was awarded at least once. Some projects like that house is awarded like 3 or 4 times, including in the MedCop21 in Paris in 2015. So these are all self-independent houses that produce its own food, produce its own water, produce its own energy. So it is an off-grid system that could be constructed and built in any remote area without any kind of infrastructure, just to act and provide the residents and the users of this houses with a complete normal life. After presenting my project, I would like to share with you guys my journey during the last 22 years. Till June 21, I was awarded 40 times. These are just the cities that had awarded me. For example, Paris, I was awarded like 6 times, but it's just one dot that represents 6 awards. And the same for Los Angeles and many other, of course, including Cairo and Alexandria, which is my home city. These are part of the awards all over the world. Also the exhibitions to spread the knowledge, to spread the word. It's all over the place. After today, I'll be adding a new orange dot in Jordan because our audience today are most from Jordan. This is part of the exhibition during 2019. It was in NASA Johnson Space Center. I contributed with 2 projects, the Lunar Oasis that I presented today, and Tree of Life, the Mars Tree of Life that I've shared with you today was also presented, and they grabbed attention of NASA engineers, thank God. Also, it is published in many venues and in many international magazines, and it was not a coincidence, or it might be a coincidence, that the same project, Tree of Life, was published on the same issue with Stephen Hawking. So starting with Stephen Hawking vision of the dystopian future, and at the same issue offering the solution. Part of the TV interview is also spreading the word, spreading the knowledge, and some of the venues that helped me to spread them, like Hassan Fathi's award, Bibliotheca Alexandria or Bible Alexander Library, Design Boom, Arch Daily, Forbes Magazine, Discovery Channel UK, NASA, and the American Institute of Aeronautics and Astronautics. I didn't just indicate it yet. And these are some of the workshops that had been conducted during the last 20 years, more than 10,000 trainees in all kind of computer technology in architectural applications. And recently I started also the space kind of training. You can find most of the lectures in different languages, from Uzbekistan to Canada, passing by Paris, passing by Cairo, and India as well, and United Kingdom, Great Britain. TEDx talks, and the visit, of course, to all of the manufacturers of the space technologies in Los Angeles during 2017. And last thing is the publishing. These are Q1 journals that have been using the same technology to achieve the net zero energy houses and to build sustainable houses for our humanity and for Earth. Last slide is the last advice that I would like to share with you today are three important quotes. The first quote says, "The future belongs to those who dare to dream." So you have to dare to dream. This is the first step. And the second quote, "The future belongs to those who believe in the beauty of their dreams." So after daring to dream, you have to believe in your dream. And the last one by Malcolm X, "The future also belongs to those who prepare for it today." So you have to dare to dream and believe to continue dreaming and take practical actions and practical steps and start preparing so you can see this dream come true someday. I would like to extend my thanks again for MVA and for Jordan Space Initiative and for Dr. Sahba for having me today. And these are my contacts. You are welcome to connect me with me, to send me any messages or just to say hi. You are all welcomed all the time. So let's keep in touch. Thank you again.
Thank you. Thank you for this really amazing, very informative presentation. We definitely learned a lot, and it's great to see your inspiring work as well. I think we'll take 10 minutes for the Q&A. We already have some questions in the chat. So Ragad was asking about the use of piezo materials and the amount of power that they generate. That they do not generate enough power essentially to power the station. So can you explain a bit more what you meant with that?
Actually, the part of your comment is really right, but science is developing, and as I've included, all of the project that is presented is built on real science, and it's developed. But the developing of any kind of technology starts with the conceptual design, then the prototyping until it reaches the commercial phase. So for the piezoelectric flooring, it is commercially manufactured in two factories, one in one of the Scandinavian countries, I think in Netherlands maybe, and there's another one in China. So the piezoelectric flooring is an existing commercial technology that is people is using in parks to generate energy, even if the energy is not enough, but we can magnify that energy using another different solution. This is the first kind of piezoelectric flooring. The other piezoelectric effect is used by the wind, by the Martian wind, and I had a situation that I would like to share with you today. In 2017, and with the supervision of our superior NASA engineer, the first initial design was a failure, total failure, according to the very weak movement of the wind on the Martian surface that will not be generating enough energy. And that was the reason for developing the second prototype with much more longer fins, using also the memory-shaped alloys. So they will be acting as energy generation device. So yeah, it could be done, it could be magnified, it could be stored and used later on.
Great, thank you. And then we have a question from Ghalia. So part of our competition is that they should include some preliminary costs and timeline estimates for the construction of the facility. And she's asking if you have any past experience or resources that can help with that part.
Yeah, I can really send you a set of literature review links, and mostly they are research published by NASA, and it is offered for free for the public domain. So I will be just emailing to Dr. Sahba, and I think she will be sharing that with you. That's easy.
Yes, definitely. We already shared a few resources with the participants, but anything that you have to share as well would be great. And another question she had was about imitating glass in space. If you could use aerogel as a suitable material.
Well, aerogel will be a very perfect shield, but it's not an airtight construction material. So I would recommend something called the ALON, A-L-O-N. A-L-O-N is the aluminum oxynitride. The aluminum oxynitride, which means, i.e., transparent metal. It is much more stronger than the bulletproof glass, because it's a metal with a low thermal conductivity relatively. So it will be acting as a natural shield. And you can just Google it and you'll find a lot of applications. And it's a very promising material. The main problem that 1 meter of the ALON or the aluminum oxynitride costs about $20,000. But what it is very costly today we have proven that by time it will decrease in expenses, and we are very smart. We will find cheaper ways in producing and fabricating those materials.
Absolutely. I think, like you said, the new technologies are there's always room for improvement on the technical and the economic side. So if the attendees have any other questions, please put them in the Q&A box. I have a question actually, because you were talking about the geometry of the construction earlier in your presentation, how circular cylindrical geometry is preferred because of the internal pressure. Does that consideration change if you're thinking about building something underground or in a lava tube, for example, or is it still better to stick with the...
According to my knowledge, and by the way, my knowledge is limited, so limited because every couple of weeks there's a new technology and we have to keep reading and learning. But according to what I have learned, even if you are building underground or building inside a lava tube, the same problem exists, which is the lack of atmosphere, the vacuum. So with a lack of vacuum, that means we need air and we need a certain level of pressure just to maintain and sustain our human life. And that doesn't exist either underground or in a lunar lava cave. So the same rules also apply. So we need solutions just to avoid sharp edges and sharp corners, and that is only existing in circular geometry. This is according to my knowledge and according to my readings in the past months, but I'm open to new inventions, and maybe while we are talking right now, a new invention is being invented or being developed. Let me just tackle a little point on the point of technology and the advancements. You know, just 200 years ago, if we are talking to one of our ancestors 200 years ago and trying to describe to them what is the video conference or a Zoom meeting that we are conducting today, he will just easier for him to understand that this is some kind of a black magic. People cannot really imagine that we are in 3 or 4 different countries talking in real time, and this is totally mind-blowing for them. 160 years ago, I'm always inspired by Jules Verne. Jules Verne is the first of the science fiction writers that imagined that we could be putting humans in a big metal barrels, and just 160 years later, we invented submarines. He also wrote about shooting a huge cannon of people to the moon, and then in 1969, we have landed our first human being on moon. So what we consider today as a challenge, I think it will be easier. And with a fast accelerating pace of technology, things will take much more less than ever. So we don't really need to just wait for another 100 years, just in maybe a decade or a couple of decades, we can see all of these challenges solved.
Yeah, absolutely. And I really liked your point during the presentation as well about reflecting on what our ancestors are doing and how we can actually carry a lot of these teachings forward. It's not just ancestors also, but a lot of indigenous communities now have a different way of living and existing in harmony with the planet, with the environment, that we can definitely learn a lot from.
And facing harsh environments.
Exactly, yeah. We do have a question from Zaid. Maybe it will be our last question. What would be more feasible to build on the moon or Mars? So using nuclear energy or renewable energy?
The first stepping stone is our backyard, which is moon. And I do believe that this is the reason behind more attention is growing and more competition is growing to colonize moon between NASA, maybe the Chinese space agency, and different space agencies. So the moon will be the starting point for us, and then it will be followed by Mars, and who knows, maybe Saturn built later on. Also, using nuclear energy or renewable energy, I think combination of both of those are important. Nuclear energy is a stable kind of power source, but it will come to end just maybe after 60 or 70 years. So the new mindset of embracing the renewable energy sources is much more feasible on the long run, even on Earth here. So I hope that this will answer the question that is offered.
Yes, for sure. Okay, so maybe just one kind of final question to help our competition participants, because you presented a lot about lunar architecture, Mars, even orbital habitats. What are the main takeaways that you think apply to analog facilities on Earth? Like keeping in mind that obviously we don't have a lot of the same challenges, but we want to simulate as closely as possible.
Well, I would like to offer an advice for our participants today. Try to focus more on developing life support systems. It is the key element that is crucial for generating oxygen, recycling water, and producing food, and the environmental waste management. And it is the main element. It is the main key, and it might extend also to power generating source. So the life support system. Read about life support system. Understand how the ISS is functioning and try to mimic most of the lunar environmental parameters to try if we have solved this. I think it is very easy for the rest of the aspects to be constructed, but this is the main point of research that needs much of their efforts.
Yeah, absolutely. I also found it very interesting when you're presenting there's the environmental control life support systems, but then also the ones more based on actual ecological solutions.
Micro ecosystem,
The controlled ecological,
natural based solution, creating a micro ecosystem. It's called also the
exactly.
bioregenerative closed loop system.
Yeah, so that reminded me actually of the biosphere too, in
Exactly,
Arizona, which is that's
exactly.
essentially what they were trying to do is simulate the entire Earth ecosystem on a smaller scale.
And it's
And
an
as
Earth
much
analog, by the
as
way. It's also considered to be an Earth analog.
exactly, yeah. I was actually there for the Analog Astronaut Conference a few months ago. It's really fascinating to see and also to hear how kind of what you were saying, it's very unpredictable because even though many years and millions of dollars went into this, just the smallest change in the ecosystem balance threw off the entire the atmospheric composition. It caused a lot of issues. So I think as with anything, it's good to have redundancies, but especially when you're doing something related to space and human life is involved as well.
Yeah, we are very smart creatures, and history had proven that we can overcome the challenges. The key element is the accumulation of experience and the transfer of knowledge. So, as we are transferring the knowledge between us and to the future generation, and we are accumulating our experience, documenting them, and passing them to our future generation, we will succeed. No doubt about it.
Absolutely. So with these inspiring words, I think we'll wrap up for today. So thank you again, Dr.
Thank you.
Salman Sayary, for joining us in our first lecture in the series. We hope that it was beneficial to our competition participants and everyone else who joined today. Of course, the recording will be available online. And if you follow us at JSRI to Space, we will be sharing more information about our upcoming talks. And of course, I will also share any resources that Dr. Salman has to share with you all. So thank you again, and I hope you have a wonderful evening.